Hello, everybody. Thank you for joining today's webinar. It is the last in a series of 5 webinars on the Lansmont 6-step method entitled Test the Product Package System. I know some of you joined us for the previous webinars in the series, so I apologize if you've heard the housekeeping bits before, but I'll just quickly run through them. So as you know, this is a Lansmont Corporation webinar. Lansmont falls under the umbrella of the Physical Properties Testers Group, or PPT for short. The PPT group consists of various expert brands specializing in the physical properties testing solutions, encompassing areas like tensile and compressive strength, torque testing, textile analysis, and real-world dynamics such as shock and vibration. The other companies within the PPT family are McMesson, James Hill, and Aluris. If you want to know more about the group or the individual brands, you can visit the PPT site and also explore the content and on-demand webinars the brands have available. I'll put a link in the chat box for you to review shortly. Most of you will know our webinar host for today, Eric Jonassen, and my name is Sharon Smarenberg. I'm one of the organizers. Then we have various support staff throughout the United States, Europe, and Asia. As always, please feel free to ask questions. You can use the question box throughout the webinar to type in any questions you may have. We will then address these questions at the end of the webinar. The webinar will be recorded, as always, and you will receive the recording at the email that you used for registration. Feel free to share the recording with colleagues who couldn't attend, or keep it on file for your own reference. And with that, I'll turn it over to Eric.
Thank you, Sharon. I'm quickly going to turn my camera on, introduce myself before I start here. So I just wanted to say thank you to Sharon for your help in putting this on. And thanks for everybody for your interest and willingness to attend. And welcome to what is right now the last webinar in this series of 6-step method webinars that we've given over the last number of months. So this is kind of the conclusion of that webinar series, and we're going to talk about testing of the product package system after we're all done with defining the environment and establishing product fragility, picking our packaging materials, designing our package. Now we test it to see if it's going to actually work and perform in the environment. So that's what we're going to be talking about today. And I do have some videos, not as many videos as I've used in some of the previous webinars, but I do have some videos, and you know, again, they might not play out all that well just due to bandwidth issues, but we will make sure that they are included in the recording at high quality, high resolution in that recording itself. So thanks for your patience on that. And I'm going to go ahead and turn my camera off as I move forward, just to save bandwidth as I present. And I should have plenty of time, or we should have plenty of time at the end if people have interest in questions about the subject and topic. So let me get moving so we can get to that point, and feel free to have an interactive discussion. Thanks again, and I'll see you on the other side. Okay, so talking about testing of the product package system, but before, one last time to look at this transport package design fundamental, because it just kind of closes the loop on what we're going to talk about today. So revisiting product durability. A robust product works together with its protective packaging to get things through the supply chain. And so those things have to work together to be, protect against all this bad stuff that happens in the supply chain. The way we look at it, once again, is in terms of, is the environment is made up of all these hazards: shock, vibration, compressive loads, and environmental, atmospheric hazards, temperature, humidity, atmospheric pressure that may occur when shipping in airplanes and over high passes. All that poses hazards. So the product in the package has to work together to get things through that supply chain. And again, I draw the dashed line across the top of this chart because it's really, in my opinion, and in the standards kind of setting and establishing of standards, it's important to understand what that, where that line lies in terms of how much hazard is there in the distribution environment or the supply chain, and being able to quantify that very, very clearly. And why is that important? Because we use that information from the supply chain really to establish the test intensities that we use in the laboratory, right? So we use that information to tell us how high we drop things, how severely we impact them from maybe a side impact perspective, and how robustly we shake them during our vibration test. All of that is established based upon, kind of a clear understanding of the environment. And we use that to set our standards, right? So either to set our, even our industry test standards, or sometimes people set their own corporate or company specific test standards. And so I'm going to talk about both of those types of scenarios as I move forward. But I'm going to start by saying some people, as far as when we talk about testing the package product system or the product package system, some people, do the simplest of all tests, which is ship tests, actual ship tests, which basically means pack it up and ship it like you might in the actual supply chain, right? So package a quantity of products, ship those products, package products through a typical supply chain channel to controlled locations, inspect for damage or performance, and repeat that. And, again, that sounds very simple, but, probably some of you that are even attending are aware, or maybe you even use ship test as your testing methodologies or practice. And sometimes people use kind of a combination of both ship test and laboratory tests, kind of correlate between the two. Some people just feel more comfortable, sending things through, getting that kind of final level of comfort or confidence by shipping things through the actual supply chain or their own distribution channels to see how well it performs. And so it's not an uncommon scenario for people to do actual over the road or over the rail ship tests. What are some of the advantages associated with ship tests? It's easy to understand, right? Easily understood. What am I doing? I'm shipping it through the supply chain. It's not a laboratory test, and how to correlate a lab test to actual transport. I'm going to actually ship it and test it and challenge it that way. So I don't need, in that case, to understand all the details associated with the distribution environment or supply chain. I don't need to understand, kind of quantified shock, vibration, compression, temperature, and humidity. If it's going to happen, it's going to happen. And so I'm going to ship it through those conditions and let it all play out on its own. It's easy to accomplish. Ship test, right? I mean, everybody, that's making product and shipping it through the supply chain, they're already practicing that. So it's kind of easy to implement, at least as far as where I'm going to, how I'm going to pack it, how I'm going to ship it, how I'm going to receive it, maybe inspect it. I don't need to understand all those hazard elements. If they're there, they're there, right? I'm going to encounter them because I'm going to ship them across the continent. And, as long as things are moving and they're being handled, they're going to experience shock and vibration. And I don't need to then simulate it in the laboratory. I don't have to figure out what tests to perform in the laboratory, right? My test is the ship test. So I don't need to pick and choose and define or create a laboratory test simulation if I'm going to do ship testing. But some of the disadvantages, very specific, right? Depending on how many shipments you might actually, ship tests you perform, but each one of those is one trip. So you have low confidence, right? You have low confidence in the results because it is what it is. And that means, was it a good, example of a good shipment, good handling, good ride? Was it bad? how do I statistically, address or consider the results on something like that? It's one trip. I can't observe the problems as they happen. I pack it up, put it on a truck, put it in an intermodal container, ship it maybe, across country, across the continent, maybe even across the ocean. I open it up on the other end. The results are what they are. And then I have to figure out, let's say there was some type of damage, what I think occurred to cause that damage. I don't really know, right? I don't know. It's out of my control. I see it before it leaves. I see it after it arrives, and I'm left to kind of figure out what occurred along the way. It can be costly and time consuming. I've been involved myself in some large scale projects with different product shippers where we at the same time perform measurement during the ship testing itself. And what that required was flying a number of people, engineers, from one location, the point of let's say production and shipping. So everyone flies in. There is packing that takes place. There is documentation associated with the as shipped conditions. You pack all these different containers up. It takes maybe a couple days to prepare everything. Everyone flies home. The product is shipped to the final destination. Everyone in this example might fly to the receiving location and spend a couple more days receiving and documenting the as received conditions. So it's kind of a costly, and it can be a costly and time consuming effort, to say the least. And once again, there's little control over the test. It is what it is. Was it good, bad, indifferent? And how do we, if you think about in terms of damage in the supply chain, even a couple percent, 1% damage rate is maybe a large number in reality. So how many actual test shipments do you have to perform to really have confidence that you've seen enough variability in your ship tests to identify whether damage is going to occur or not? So there is, again, disadvantages and risks associated with just performing ship tests. Those hazards and damaging levels may or may not occur, especially when you think of things in terms of handling, handling and shock, which is a more transient type of activity. It may or may not occur. Vibration, anytime anything is moving, it's going to experience vibration, maybe even compression. But from the handling perspective, it's a more transient type of an occurrence. There's certain probabilities associated whether things are going to take big impacts or be dropped, and that may or may not occur. And so you have to run a number of replicate ship tests to maybe identify that. So why would we then test in the lab? And these are some, this just laboratory testing equipment. Obviously, this is a Landsmont presentation. I'm showing Landsmont laboratory test equipment in this example. But why do we do laboratory testing versus ship testing? It's because the reality is the real world is large and complex, meaning there's all kinds of different complexities associated with the supply chain, especially from the global perspective. How I ship things. Is it by truck? Is it by aircraft? Is it by rail? Is it by intermodal container? Is it over the ocean? Is it a North American only shipment? Is it North America to Europe? Is it Asia to Europe? Is it Europe to Latin America or South America? And there again might be complexities associated with each of those types of scenarios, the modes of transport, but also the geographic locations associated with that, the destination, origins and destinations. And so in testing the lab, we need to be able to predict, and that's kind of a key word that I like to use and refer to when talking about laboratory testing, because we want to predict how well packaged product designs will work. That's what it really boils down to for the most part when what I'm talking about today, and when people are performing this type of testing. It's exactly what we're trying to do. We're trying to get a good idea, predicting how well our packaged product is going to perform once it gets out there in the supply chain. And so lab tests create this miniature universe. These lab tests, create this miniature universe, which means simulating supply chains, very specific supply chains or supply chain channels. And so we're able to create that, and we can control that, right? In a lab, we control the procedures, we control the specific inputs associated with those procedures. We can control how we drop things, the orientation of how we drop them, how high we drop them, and we can repeat that. So it's controllable, it's repeatable, and when we're in the laboratory, we can observe it up close, right? So we have the ability, one way or the other, either a lab, maybe it's a third-party lab who's running testing for a company, they have the ability to record all that and observe it in real time. Or if you're doing your own testing, it's very, very powerful to be able to see how things perform when exposing those or subjecting those to those types of dynamics. Walk right up and stand there, be there for the drop test, the compression testing, or the vibration testing to see how things are responding to those inputs. The more accurate our universe, the higher quality our answers, meaning the more we know about the supply chain, specific supply chain or modes, the higher quality or the higher confidence we get from the testing results, meaning the answers associated with the testing. Unknowns or uncertainties cause us to increase test severity. So a lot of times when we're talking about distribution simulation testing, whether it's, for instance, ASTM, ISTA, or ISO, those tests are intentionally, the inputs oftentimes considered to be using or referring to accelerated test levels, especially, let's say, from the vibration side of things. We're biasing the tests towards more severe inputs. And again, those, it's not artificially severe. It's based upon some known elements or quantifications of the supply chain. But as one of the ways that some colleagues refer to the testing, we gear things towards the instead of being normal, quote unquote, normal distribution, we gear our test inputs to what would we call or refer to as worst of normal. Or think of the 95th, 99th percentile types of amplitudes of shock and vibration, or again that simple terminology of worst of normal. So we increase test severity. And this testing is an evaluation to support decisions, usually to support all kinds of decisions, but design. You can support design of products, and it can design or support design of the package system that's used to transport those products. And what we really, another key word that I like to focus on is it allows people to develop and establish confidence, right? Confidence is another word used, especially on the quality side of things, is that's what we get, from using laboratory testing. When it's using good procedures and you're documenting and observing things, you're able to establish a level of confidence associated with how well your packaged product is going to perform in the supply chain. Why? Because you're there. Those pictures are just examples of stuff that's undergoing testing, but also the idea of people being there and observing how things are performing and or responding to those testing inputs. This is a video, no sound, but just a video, just to see incrementally. If we see it with our own eyes, I can control these inputs, maybe increasing the inputs every time to challenge the loads to establish how well they're going to perform. And again, that's just the power of being able to control the inputs, to observe, to document, and establish confidence one way or the other in how well things are going to perform. It also allows you to change, for instance, your packaging design and retest. And so you can do comparative testing, right? To say how well is one, in that previous video example, how well is one packaging or wrapping design going to work as compared to the next one. If I add tension, I add stretch, I add number of rotations of wrapping revolutions, is it going to perform better, worse, different film? Again, I then am able to establish confidence in my decision as I move forward. So distribution simulation testing, that's what I'll call this. That's what I'm going to focus on, is distribution simulation testing, where we're actually simulating the transport of a packaged product through the supply chain. And so when I talk about distribution simulation testing, I will refer to industry test standards. These are the big ones that I'm going to talk about. I'm really going to focus primarily on ASTM and ISTA moving forward. ISO test procedures are similar, quite frankly, in their the inclusion of the dynamic testing that's performed and even the amplitudes. But I'm going to focus on ASTM and ISTA as I move forward from the industry side of things. And I'm also going to talk a little bit about corporate standards, corporate test standards. But one way or the other, there's a lot of similarity between, I would say, either the industry test standards or even corporate standards, which for the most part, I would say corporate standards that people use are some type of iteration of an industry standard, where someone might base it upon an ISTA or an ASTM test spec, but they might change up the vibration testing one way or the other. They might increase the intensity of a profile. They might change the duration of a profile for some, historical reason or precedent on their side. But usually it is all based one way or the other on, I would say, industry test standards, even the corporate standards. So ASTM Committee D10 on packaging. Okay, so that's a big organization, ASTM, but there's a specific, D10 is specific to packaging. And so this is a spec sheet about ASTM D10 that talks about the scope. And again, there's a lot of detail here, and this is a PDF document that's available on the ASTM D10 site. And you can download this, or I'm happy to provide it to anyone that's interested. But it talks about the scope of D10 on packaging. It talks about the technical subcommittees that are involved. Let me just see if I can change my laser pointer here. So you can hopefully see my laser pointer, but this talks about scope. This talks about the technical subcommittees. So there are a number of subcommittees within ASTM D10 that focus on different areas like hazardous materials, sustainability and recycling, shipping containers and systems, performance test methods, and what it within ASTM D10, there are a number of test standards, right? So that over here on the right-hand side, you can see that up here, I'll move my laser pointer out of the way now, just use the arrows, but there are 132 standards as part of the ASTM D10 on packaging itself. A lot of standards involved here. And these guys meet, anybody that's a member of ASTM D10 can join meetings that occur twice a year. They meet in person twice a year, in April, in the spring, and in October. And where the subcommittees that are listed over on the left-hand side have the opportunity to get together and present if and as needed or warranted on any relevant updates. And so the meetings actually for D10 just occurred last week in Washington, D.C. They just occurred and ended beginning of last week in Washington, D.C. And so this is, again, a group that anybody, it's individual members. So it's not really a company membership organization, it's individual members. Anyone can join this group and follow this group. The membership cost is very reasonable for individuals. And, as part of being a member, you then have the ability to participate. So it's not like, you just pay attention. I mean, it can be that you just pay attention to what's being published, to the output of this group, but you have the ability to become involved and participate in these meetings, and also to potentially participate in technical work groups that are looking at standards, and updating standards. This is something that I personally myself get involved in and have been involved in. I'll touch on that in a minute. But you have the ability, so that's powerful. And the most relevant, when we talk about distribution simulation test procedures, the most relevant standard within D10 would be D4169, which I've highlighted here down on the left, which is a standard practice for performing testing of shipping containers and systems. That's a very well-known, widely used, referred to test standard that's been around for a very long time, and really, quite frankly, served as one of the foundations of my company, Lansmont, back in the early let's say the 1980s, was really helped to really grow our company one way or the other, providing equipment or testing capability that delivered 4169 testing performance capabilities. So ASTM D4169, the initial development of D4169 started in 1979. This is just kind of a copy of what that study was. This is called the FPL 22, which stands for Forest Products Laboratory Technical Report 22, which was back in the day called an assessment of the common carrier shipping environment. So in 1979, this large scale study, this document is available in a number of different places. I have a copy of it. I think it can be purchased online, but it really serves as the foundation of ASTM 4169, where folks at the FPL, Forest Products Laboratory, went out and did a large scale environmental study of that common carrier environment, where they went and looked at truck data, rail car data, aircraft data, shipping data in terms of drop heights with instrumentation, in terms of vibration with instrumentation. It looks very, looks like what you might expect in 1979 compared to 2023, but it happened. It was, and again, people ask questions, quite often, myself included, when you look at test standards, to say, where did this come from? What is this based upon? And this is just an example, digging way back into the history of, let's say, ASTM 4169, where it all started. That doesn't mean it's still based upon, that things haven't changed since 1979, but it started here, right? It started in 1979 and has grown into something obviously much more significant since then, and has changed over the years, over those, 40, 50 years, to something where now, which is a lot of information also as part of this page that I'm showing, but basically showing that 4169 is now, even as recent as the 2022 document, revision of the document. There are 18, there's a number of distribution cycles that are part of ASTM 4169. So just might be too hard to see some of the detail here, but single package on a pallet, motor freight shipping, rail only shipping, rail, trailer on flat car, container on flat car, air intercity shipping, export shipping, non-commercial government shipments. Those are all different, very specific, what they call distribution cycles, DCs, or distribution cycles, where you then have different testing inputs associated with those that then are stitched together sequentially, these testing inputs. So if I look even for a single package without pallet or skid, it says Schedule A. We do handling, we do stacked vibration, we do loose load vibration, we do concentrated impact testing, and then we do another round of handling, which typically means impact or drop testing. So there are all these different distribution cycles that exist today as part of 4169. again, that grows over time, and that is subject to change and updating, or even addition to, if as warranted, that a new mode of distribution, a new channel of distribution is developed. There may be a new distribution cycle that gets added to this document or this test procedure that you can choose from and perform. From an updating perspective, what I can tell you is I've been involved myself in a couple of big updates back in 2016, which was for a vibration profile updating of the truck vibration profiles that were part of 4169, assurance levels 1, 2, and 3. We kind of took a look at that, took a look as a part of a work group, whether those profiles were still representative of what's out there in the supply chain, both in terms of their shape and their amplitude, and whether or not they needed to be changed. So we took a look at that in 2016 and did recommend changes to the profiles. And then we did the same kind of an effort in looking at the air profiles. And so I say this happened in 2016 and 2022 for the air, but what that really means is the effort occurred before that, and then during 2016, the revisions were voted upon and accepted, and then the same thing for the air. All the work was voted upon and accepted in 2022 to change those. And the point I'm making here is that when the updating occurred, again, back to questions people have associated with why did it change? What was involved in the change, or what's the basis for the change? And so these are just a couple, screenshots of the front page of each of what we called, in this case, a rationale document. So what we did was we kind of took it upon ourselves, the people who were part of this work group, that said, if we're going to go through this effort and recommend a change, we're going to create a document, one way or the other, that explains what we did, how we went about it, and what our recommendations are, and basically forms the basis of why we're recommending the changes, and that's was submitted, and was available to the membership of ASTM, to take a look at, review, agree or disagree, and then once it went to ballot, to be voted upon. And again, these types of organizations, whether it's ASTM or even ISTA, they're membership organizations, they're volunteer organizations. So, work groups, sometimes changes is challenging from a resource perspective and from a time perspective. How do you implement change? How do you fund the effort to justify or fund the effort to make these changes if they're warranted? So what we did anyway, as part of these work groups, is document it. And again, people can agree or disagree, but we had to at least say, hey, here's what we recommend. Here's why we're recommending it. And it's up to you, all to review and either agree or disagree. But that process exists, and you can participate in these types of efforts in the standards organizations, whether it's ASTM or ISTA, to participate in these. Not just sit back and wait for it to come one way or the other, but you can participate if you have an interest or the ability or expertise to help with these efforts. And then the other thing that within ASTM D10, there is a test procedure called ASTM 6537, which stands for, or which is defined as the standard practice for instrumented package shock testing for determination of package performance. And so what that really means is, these are just some screen captures, again, from a couple of the pages out of that document. It's a longer document than just 2 pages, but what this also provides is some guidance. When we talk about distribution simulation test procedures, the whether it's ASTM or ISTA, there tend to be pass-fail, right? So you put them through maybe drop testing, vibration testing, compression testing, and then maybe another round of drop testing at the end of it, and then you take a look at it and you say, am I good, or is there damage? Again, I'm trying to establish confidence one way or the other how well things work, and so. What I want to point out is that, in addition to pass-fail kind of criteria, there is the ability, there are such things as instrumentation that can measure how well the packaging, the protective packaging itself performed from an acceleration or shock and both shock and vibration perspective. You can instrument things, not only can you test them, but you can instrument them, especially if you're testing different iterations of a design to say, did I do better, or worse than, did design 3 perform as good as design 2 or design 1, or was there incrementally some type of, added performance or acceptable or unacceptable performance associated with these? So it takes it more from a qualitative assessment to a quantitative assessment. And that's, there is a procedure in ASTM that walks through how you go about defining on how you do it, type of instrumentation, the type of setup you would use for making that assessment. All right, so now switching gears, talking about ISTA a little bit here. ISTA it's an ANSI accredited standards development organization. That basically means, again, that their development methodology is ANSI accredited. So that's, adds a level of validity to, not that it, any of us that are heavily involved in ISTA needed to understand this, but it does add a level of credibility associated with the organization, and it allows these their ISTA test procedures to be used and referenced, for instance, by, let's say, the FDA from the medical side of things, medical device, pharmaceuticals, and biologic types of products. Anybody shipping those kind of products that are dealing with regulatory requirements, the ANSI accreditation adds significant value from the ISO side of things. So they are an ANSI accredited standards developer. They have 2 categories of tests that they really, differentiate between: screening tests and predictive tests. So again, there's that word that I mentioned earlier, was prediction or predictive. But screening and predictive. Screening you can think of as a kind of a, just a simpler test, which basically means, I'm overstating it, but beat the heck out of it from a shock side of things. Drop it a bunch of times from maybe relatively severe drop heights, and then shake the heck out of it for a short period of time, and then take a look at it. How did it do? And now if I have 5 different, again, design iterations of a packaged product system, put all 5 of those through that screening test, and if one, or you see some differentiating performance between those, it allows you to say design 4 did better than all the other designs. And so let's focus on that moving forward. Whereas predictive testing is more of a focused on trying to, closer to a simulation of your or a given distribution environment. You're really trying to, in this case, predict how well it's going to perform. So you're more focused on, I would say, using representative test levels and intensities as part of that testing, where screening, that stuff is not necessarily, screening tests are not necessarily, the inputs and intensities are not linked to real world necessarily conditions. And ISTA tests are broken into 3 main types. And I'll break these even further on the next slide, but basically the 3 main types are non-simulation integrity test, think screening; general simulation test, think predictive; and then focus simulation, which means focus simulation is really more towards, I want to simulate exactly what happens in my supply chain based upon data that was captured specifically from my supply chain. So it gets very focused. Whereas general simulation means I generally want to simulate a truck shipment or an international ocean shipment. So it's more generalized data versus very focused simulation that is geared or pulled from measurements made from specific supply chain channels. So the ISTA test series, this is what they look like. So we break the, we call the test procedures, or we break them into what we call test series in ISTA. And there are 5 of them. And so what the main categories, what I just showed on the previous, was non-simulation integrity, general simulation, and focus simulation. And so you see those. Here's the non-simulation, here's the general simulation, and here's the focus simulation. 1 series, 3 series, 5 series. What the 2 and the 4 series are really kind of combinations of each of those. So a 2 series test is made up of non-simulation inputs, series 1 inputs, and some general simulation inputs. And a 4 series test is made up of some general simulation inputs, but also some focus simulation inputs. For instance, if I went and recorded vibration data from India, from rail cars, and that's part of what I want to simulate, but I don't know much about necessarily about the drops conditions in India, or rail impact conditions in India. I can use a combination of general simulation inputs that exist for those types of dynamics, but add to it the vibration specific profiles from India rail cars, and I would call that an enhanced simulation test or a 4 series test within ISTA. And so there is kind of a method to that flow, or method to how that structure works. So this is, as far as the specific test procedures, this is off of the ISTA website, ista.org, test_procedures, and this is what they look like. So this is, kind of showing the non-simulation test in the upper left, the partial simulation test, the 2 series, general simulation, enhanced simulation, and then they have what are called member performance tests, which a lot of people that are familiar with ISTA are familiar with the ISTA 6 Amazon test. There's an ISTA 6 Sam's Club test, and there are ISTA 6 FedEx tests. And so those are very specific, company or member performance test procedures that exist that are still, probably based at some level on general simulation types of inputs from those modes, or that were made based upon some unique characteristics in their supply chain. But this, it's an interesting or a nice, I think, helpful page that shows what the different categories are, or the test series, and lists the specific test procedures. So a 1A, 1B, 1C, 1D, 1E, 1G, and 1H are all individual test procedures that fit under the non-simulation test categories. There are 3 test procedures, 2A, 2B, 2C, as part of partial simulation, and there are a number of them in the general simulation test. What I would say from my perspective is the general simulation tests within ISTA are the most widely used as a category, widely used test procedures within the overall repository of ISTA test procedures, and that's because they're good test procedures. They're good. They're general simulation tests, and what that means is that anything in a general simulation test has to include all 4 of the main hazards that exist in the supply chain, which means they all include an element or more of shock, vibration, compression, and atmospheric conditioning. Every one of those, 3A, 3B, 3E, 3F, 3H, 3K, and 3L, would include all those hazards. So you're not missing out on any of those, very real and very, the present hazards that exist in the supply chain. So, I would say most of the activity today within ISTA, again, this is my personal perspective, and just so you know, I guess a disclaimer, I am personally involved in ASTM activities for D10 activities, meaning from the measurement and procedure updates and review side of things, but I'm also on the global board of directors of ISTA, and I'm historically very active in helping with measurement and potential updates of test procedures. So I have opinions, as do anybody who's a member of ISTA, and part of what I'm providing here are is based on again my activity in all these organizations and all this type of activity. So I like the general simulation test because I think they have because they do include all 4 of those hazards, and because of the amount of testing that is performed by not only ISTA members but even ISTA non-members, but the amount of testing that's performed and the amount of feedback that they get associated with these helps to really over time fine-tune the test procedures and tell you as a user how well they're working, and if they're not, quite frankly, what ISTA has, I mean even ASTM has it, with some regularity, you take a look at the test procedures to say, are they still meeting the objective? Are they still adding benefit? And if not, do we need to update them for any reason? And so I think ISTA has a real good procedure for internal procedure for how they review and assess the effectiveness of their test procedures. This is just another way of looking at, similar to kind of the that page out of the ASTM 4169 in terms of the distribution cycles. This is a way of looking at all of the different ISTA test procedures, regardless of their test series, or the 1, 2, 3, 4, 5, 6, and 7. But by distribution type, so parcel delivery, LTL shipments, e-commerce shipments, club store, European consumer goods, custom test procedures. This is a nice way of looking at what those test procedures are that meet that distribution type, as well as then against what type of packaged product scenario that you have. Is it 150 pounds or less, meaning comparably small? Is it 150 pounds or greater? Or is it a full unit load? So you can kind of quickly look at this matrix and see what test procedures might be applicable for your specific scenario. So there's a lot of them. There's again, I forget what the number is, but I think it's over 20 that exist, and that continues to be looked at and grow over time. And the other thing that I'd mention about ISTA is that's unique about ISTA is that they have the ability to not only develop, develop and maintain or update test procedures, but they now have the ability and structure to fund research associated with better understanding or continual understanding of the global supply chain. So one of the initiatives or the groups that they have within ISTA is called the Advocate Research and Value Delivery Program. And so there are 23 members associated with that ISTA Advocate group. And this is a screenshot of who makes up those members. We, again, just to be clear, Landsmont is a member of the Advocate Council. That means we are one of the 23 members that pledged money to help support and fund this effort. And so we have basically a say on the council, as do the other members, as to what research is going to either is being recommended or voted on or approved to move forward. So there's, this group basically, it wasn't quite $2 million, but pledged upwards of $2 million to fund or conduct research and data collection that improves testing, design methodologies to keep pace with the rapidly evolving global supply chain and enhance knowledge of existing channels. So that might not sound like that big a deal, but I can tell you that it is. Anybody that does any type of kind of measurement and analysis of the supply chain knows that it takes an effort, right? It takes resources, it takes time, it takes effort to go out and do these things, even in the simplest form, even if it's observation. Standards, whether it's ISTA or ASTM, they don't exist or make any progress without people involved, right? It takes some type of an effort to make these things move forward. And so having money, and the ability to fund these efforts is a big deal, and that's a nice thing that ISTA performs. It doesn't mean that ISTA goes out and does the effort, but they are able to put bids out, based upon what research is needed or of interest to the membership or to the advocate research group. We take a look at that, and we are able to vote, and approve to move forward on specific measurements or efforts. Research efforts doesn't necessarily all have to be measurement related, but research efforts. And then they bid that out, and then they bid that out and give those established contracts to people to go out and do that research. What type of research? This is just to give you a couple examples. One of the things that ISTA does also is they have a data collection program. This is right from their website. Talks about the priorities associated with their data collection to go out and measure all these hazards that exist in the supply chain. What are the priorities for ISTA in looking at this? They're down in the fine detail right there. It says collect data for top 5 regional land routes of interest. And so what that says is China, India, European Union, Mexico, and Japan are all identified as key areas of interest where we as an organization want to go and perform more research into the developing a better understanding of those unique and potentially unique supply chains and the hazards within those. And up to this point, 3 of those big research efforts have been completed. Started with India. Actually, I don't have these in necessarily the proper order, but India was the first one, big study that took place to go and research the specific environment within India. The European Union was next, and China is just being completed right now. And actually, we had an ISTA advocate research group meeting yesterday, and that was the results of that were presented as part of that meeting. And I personally have taken part in some of this effort, and I mention this just because what I say is that the research is pretty substantive. This is not small efforts. These are large-scale efforts. European data collection study was something that I participated in with Smithers, who is based in the UK. And then we also supported a large single parcel shipping environment study that ISTA did, where they did over 1,000 instrumented shipments of different size packages and different weight packages through the parcel delivery system, UPS, FedEx, the United States Postal Service, 1,000 measurements. So this is not like small kind of individual studies. These are really substantive studies where the ISTA is really developing a large repository of meaningful, actionable data moving forward. And then the last thing I just want to say, what we use, corporate standards. What's a corporate standard? What is that really? What do I mean by that? Well, this is what I get involved in myself personally quite a bit, where people come to me or other people that say, listen, we passed the industry standard test. Maybe it's the ASTM test. Maybe it's the ISTA test. We passed the test, but we experienced damage. We're still experiencing damage in the transport system, and we don't know why. Alternatively, we have no problems historically with damage in the supply chain, but now we're failing the test. And so there's like a disconnect there, either pass the test but have damage in the supply chain, or I don't really have any history of damage in the supply chain with this packaged product, but when I try to test it in the lab, I can't pass the test. So there's, again, a disconnect there. And so in other situations, there are people with high value, high risk scenarios, expensive products, or let's say biologic products that might be injected into the human body. And so there is more risk associated with whether things have damage or not in supply chain, and there might be issues where there's less clear understanding of an environment or the modes of transport. So I get involved in a lot of these types of studies where we're doing measurement and observation of supply chains to try to identify those unknowns and quantify those unknowns so that we can maybe develop specific testing inputs that simulate those unknowns. And it might be, again, some of the inputs where we're adding to or tweaking their, an ISTA test or an ASTM test, but we're adding an element, or we're increasing the intensity or changing the shape of a profile associated with that. But they then would consider that to be their corporate standard that they then document and control from their side. And then, the last one I would just mention is like regulated industries. And specifically, I talk about biologics. This is something that I've been working on myself here over the last couple of years with various shippers of biologic products. That's a picture of a protein, of a molecule. It's a high value. They ship in atmospherically controlled transport environments, meaning both temperature side of things, but also they ship by air often, right? So there's a high altitude, atmospheric pressure specific concerns where that could change or affect the performance of packaging. The efficacy of the product is certainly critical. It's got to work. It's going to go in somebody's body potentially on the other end. So there's no tolerance for damage. It's hard to understand the fragility of that molecule. We know it's fragile, but we don't know how to define the fragility of it. We just know they don't like shock or vibration. There's no specific test requirement for things like, that the FDA, for instance, on that regulated industry, they don't specify a test requirement. They just say, whatever you do, darn well better simulate the environment. You better know your distribution environment, and any testing that you perform better simulate that environment. And you better be able to stand behind that or defend yourself for what you're doing. And so in those situations, people, the shippers of those products, they don't want to overtest things. There's a risk of overtesting, and there's a risk of undertesting. If I overtest something or my inputs are too severe and I damage the product as part of the test, that has huge implications, because I don't just necessarily go back to the drawing board and repackage it and try to retest it. There are studies, investigative studies that have to occur that can be hugely costly and time consuming in a number of ways. But we also don't want to undertest, right? We don't want to, there's just huge risks involved on either side of that. And so there's a lot of effort with those types of companies to design right now their own company specific testing profiles that provide to them that just right, I'll call it kind of just right confidence. Okay, I know I'm right at about an hour. I apologize. I like to talk a lot, but I'm right at about an hour. So I'm going to end with that. Trying to give a broad overview. I'm happy to answer any questions for anybody that's still online, and obviously happy to answer questions from an email perspective. So thank you, everybody. Thanks, Sharon. I'm going to turn my camera on and mute my microphone for a minute.
Thanks so much for that, Eric. Now is the time. If you have any questions, please pop it for us into the question box right now. I'll give everybody just a minute or so to gather their thoughts as they do that. And just a reminder that you can reach out to Eric if you have questions following this webinar, and his address is just eric.jonassen@pptgroup.com. But there is a question that's come in. It's, do you see the demand for multi-axis vibration testing with 6 degrees of freedom increasing?
I turn my mic. Can you hear me all right? No, just make sure you can hear me. So
I can hear you. Thank you.
Okay. Yeah. So I do believe there's a place for multi-degree of freedom testing. We support that. We've sold those products ourselves in the past, and believe that it's got a place. Believe in the value of it. Not necessarily for everybody, and depends. I think it's product specific or environment specific. It's product in the configuration of the packaged product where I think it might make a difference. Um, and there is research still that's continuing in that space. That's part of the problem associated with it right now. I would say is that there's not a lot of standards, right, that exist associated with it. Even though it makes sense because it's more realistic, it's closer to reality, depending on how complex. If it's multi-degree of freedom means basically more than just one axes of input. So it could be 2, 3, 4, 5, 6 degrees of freedom. So what are the right number of degrees of freedom, and what are the right testing profiles or inputs that somebody would use from a standardization perspective? So I think there's opportunity for that to grow, and the acceptance and comfort level associated with that. There needs to be standards associated with it. And I'm familiar with some standards efforts that are taking place in Europe, a group called UMOS, or WAMOS, EUMOS, that's taking a look at this. And I can tell you there's another distribution consortium group that's being headed up at Michigan State University at their School of Packaging, where they have a multi-degree of freedom test system. So they're planned to do research in that space moving forward, probably starting right after the first of this year. They just got that system installed and up and running within the last couple months. And I myself personally live close to that system. I have an interest in that, and there's a number of pieces of equipment that are part of that distribution consortium, including the Landsmont load stability test sled. So we're active members of that distribution consortium, and I'm looking forward to see what comes out of that from even the multi-degree of freedom testing perspective. So that might help us, let's say as an industry or a testing community, move forward from general interest to something that we can actually, implement one way or the other. Even if we start simple and eventually move to something more complex, what do we do? What is it that we use, and how do we use it, quite frankly, moving forward? So that's a long response, but happy to answer more if anybody would want to email me about it.
Thanks, Eric. I think that's the questions that we have for today. So everybody, thank you so much for joining us again for this whole series of webinars, not just for today. And we hope that you will join us again next year as we roll out a whole new host of webinars, and we will we look forward to hosting you again. So thank you very much for that. And for now, we're going to end the webinar.
Thank you, everybody. Thank you, Sharon, as usual. Appreciate your interest.
Thanks, Eric.